Okay, here's the first analytical geometry question. They give you all these points, A, B, C. They give you all those points. They tell you that there's a point out here called D. They don't tell you what it is. But they say AD is parallel to BC. They say that N is the x-intercept, I think. It intersects, right there, at T and 0. Well, because the y-coordinate's 0, they're telling you that's the x-intercept. And that's important to know. That's an x-intercept at E, too. BD and AC intersect at M. These two lines cross at M. Okay, calculate the gradient of BC. Well, there's an easy one. All we do is look at B and look at C and subtract the y-coordinates. 5 minus 3, that's 5 plus 3. 6 minus 0, is equal to 8 over 6, which reduces to 4 over 3. There's the gradient of BC. Determine the equation of AD. Well, let's take a look at that. Determine the equation of AD. Well, they told us that BC and AD are parallel. Well, there's the big trick. We've got the gradient of BC, so the gradient of AD's got to be exactly the same. So you write that down. The gradient of BC equals AD, which is 4/3, 4 over 3, because BC is parallel to AD. It was given. Well, that gives us half the answer. We can put 4/3 x in there. Then just take the point A, put the x value in there for x, put the y value of 2 in there for y, and you multiply it out. And what are you going to get? You're going to get minus 8 over 3. And then you go 2 plus 8 over 3. If you can do fractions, or your calculator can do it, C is 14 over 3. So there's your equation. So you add 8 over 3 to 2, and you get C, the y-intercept. So y equals 4/3 x mx plus this y-intercept of 14 over 3. And that's pretty good, because now you've got the equation of AD right there. You know it crosses up here at 14 over 3. That's the y-intercept. So there you go.